This is the exponent rule for powers being raised to other powers. If you have not yet watched the other exponent rules videos, so negative and zero exponents, multiplication rule, and division rule, I highly recommend doing that as those will be referenced later in this video. So one more recap of exponents being a way to represent repeated multiplication. Okay, this is still an idea we can use to help support our rules and to kind of back them up and justify why they happen. It can help us also get around them. If you don't remember them in action, you can just use the fact that exponents are repeated multiplication to help you be able to simplify your problem anyway. So remember that if you see something multiplied by itself, you can rewrite that with an exponent. So I see 1, 2, 3, 4, 5, 6 m's. So that can be written like m to the sixth. And if I see a term, I'm also allowed to spread that out and say that this is 3 being multiplied with 4 x's and 2 y's, all separated by multiplication. All right, so for the power to power rule itself, coefficients are where people tend to actually make their most mistakes in the power to power rule. So coefficients are gonna end up getting raised to the outside power. So exponents are going to act the way that they normally would with the biggest numbers. So if you see 3 to the 5th power, or 3 or 5 is the outside power there, 3 is going to get multiplied by itself 5 times. So I'm going to have 3 times 3 times 3 times 3 times 1 last 3. So 1, 2, 3, 4, 5. Now that's going to give me an answer that is 243. That's the way that we want to treat our exponents and our coefficients here. What you do not want to do, and it's the easy common error to be made, is to take 3 times 5 and turn that into 15. That is not what we're trying to do here. But that's going to be your tendency because of what happens with the exponents. Your exponents are going to multiply. So the process itself is almost kind of loosely like the distributive property. So people get really excited and just try to multiply everything, but that's not going to work so well with your coefficients. So also another common thing is that if people get this part right, then they start taking everything to an exponent. So don't use exponents the way that you normally would on other exponents. So exponents can't square other exponents or cube or anything else like that. Again, exponents of 1 might cause a little bit of trouble just because we forget that they're there and thus forget to use them. So here's how our rule is going to work. Looking at our very first example, we're going to see x to the 3rd to the 4th power. So what will happen to use our rules? We're going to end up taking that 4 times that 3, and 4 times 3 is just going to make 12. So my final answer is going to be x to the 12th power. So think about what that really means. If we see x to the 3rd to the 4th power, it means that x to the 3rd is getting multiplied by itself 4 times. So that would be like seeing x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And we can turn it into a multiplication problem. If you use your multiplication rule, you can confirm that 3 plus 3 plus 3 plus 3 still makes 12. Even if the multiplication rule is something that you struggle with, you can break this down even farther. You can say that x to the 3rd is 3x's, and you have that happening 4 times. And from here, you can just count and see that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, again to confirm. So that's what's really happening with the power to power rule and why it actually works. It's a helpful idea to know what's happening, and that can help you troubleshoot your coefficients if you start making mistakes. So when I see 3x to the 5th squared, if you cover up the variable, this is saying to do 3 squared, not 3 times 2. So 3 squared does make 9, and I'm going to multiply my exponents. 2 times 5 is going to make 10. So 9x to the 10th is the answer I'm supposed to have. And again, we can back it up using this idea again. So what this means is that 3x to the 5th is happening 2 times. So when it's written this way, it's easier to see that you're doing 3 times 3 rather than 3 times 2. That, again, is the common error. So you can use that multiplication rule to confirm 3 times 3 does make 9. 5 plus 5 does make 10. Again, if you feel that you need the extra step here, you can pause the video now and write that out if you feel like you need to confirm it at this point. Otherwise, I'm going to move on to the next example. So our next example gets 2 variables going on. It also has an exponent of 1 in there. If it helps to write those in, please do. It can help you remember to make sure that you don't leave that out. Now, as I multiply, this is where it feels kind of like the distributive property. I'm going to make sure that that 5 gets multiplied by the 3 and that that 5 gets multiplied by this 1. So I'm going to end up with x to the 15th power, because 3 times 5 makes 15, and y to the 5th power. Again, you can confirm. We have 3xy, sorry, x to the 3rd y, happening 5 times. And this is where those exponents of 1 can also be seen that you're going to end up with more than just a single y in your problem. So I can do 3 plus 3 plus 3 plus 3 plus 3 to get 15, and I have 1, 2, 3, 4, 5 y's also to help confirm. That'll probably be the last problem that I write out that way. All right, on this bigger problem, again, we want to treat those coefficients the way that exponents normally would treat that 5. So I would have 5 to the 3rd power, so 5 times 5 times 5 to make 125. And then otherwise I'm going to multiply my exponents. 3 times 10 will make 30. 3 times 2 will make 6. And 3 times 1 on the c will make c to the 3rd power. All right, this can also happen across division as well. And this whole repeated writing it out again also works to kind of help justify and show you where things are coming from. So you can distribute this as well. So I'm going to take the 4 times the 3 and the 4 times the 2 on the bottom. So this will look like x to the 12th, because 3 times 4 is 12. And 4 times 2 will make 8 down there on the bottom on the y. Now remember, if you think back to the division rule, I can't do any more simplifying here because I have different variables. All right, if we throw some coefficients in there, it still works the same way. I'm going to end up doing 2 squared, which is 4. That one's a little bit forgiving because if you accidentally do 2 times 2, you still get the right answer on that one. But 3 is not forgiving in that way. If I do 3 times 2, I'll get 6, and that is not the right answer. Instead, I want 3 squared, which will make 9 for my coefficients. My exponents are going to multiply, so 7 times 2 on the A will make 14 on top, and 2 times 4 on the bottom will make 8. Nothing to reduce, so that makes my final answer. Now, as a challenge, and kind of to extend this, you can also mix and match all of the rules that we've talked about over the last few videos. So in both of these problems, we have a couple of rules going on. So here, I see some multiplication between 2 separate terms, and I see this power to power rule. In the second, I see some division and the power to power thing happening as well. So I have a couple of options to be able to solve these problems. I can treat this like the power to power rule first, but then I will still have things that I'm allowed to combine. If after doing one step, you still have multiples of the same variable or big numbers that you can combine, you should combine them to put things in simplest form. So my first option here is to take care of the power to power rule first. So what that would look like is doing 2 to the 3rd power to get 8. 3 times 5 on the exponent to get 15. I'm going to do the same to the other term. It is inside the parentheses. So 3 to the 3rd power makes 27. And 3 times 4 is going to make 12. So now I have some multiplication. So my rule changes a little bit. So this is where we multiply our coefficients and we add our exponents. So that would be 216. X and 15 plus 12 makes 27. So 216x to the 27th. Now, the nice thing about these is that they are pretty flexible. If you are kind of thinking more along the lines of PEMDAS and doing things inside the parentheses before you continue, you can do that. So what this would look like in that case is doing 2 times 3 to get 6, and doing that multiplication rule first, 5 plus 4 to give you 9. Doing it this way does cause a little bit of trouble. Sometimes people will drop this or forget that it's there because they get caught up on doing the actual multiplication. So if I do 6 to the 3rd power, I get 216. And if I multiply my exponents doing the power to power rule second, I still get the same answer. So either way is right. Similar deal here on the division. If I do this, I can square everything first and use that power to power rule. So 12 squared makes 144. 2 times 2 makes 4. 2 times 8 makes 16. Okay, on the bottom, 3 squared is 9. 2 times 5 using that power to power rule is going to make 10. And 2 times that 1 that's there will just make 2. Okay, now notice I still have a couple of x's and a couple of y's that I can reduce. Surprisingly, also 144 and 9 reduce. They actually divide. So 144 divided by 9 actually makes 16. If I do my x's here, I'd have 4 minus 10, which makes negative 6. Basically, that's letting me know that that x to the 6 needs to be on the bottom. And 16 minus 2, using that division rule, is going to make 14 up there on the top. And that makes my final answer. Or, and this is the way that I would prefer to do these problems, or this particular problem, is I would reduce on the inside first and do the division. So what this does for me is it gives me smaller numbers to work with. So here I've made my numbers really big and then have to reduce the big numbers. Here, if I do 12 divided by 3, I get 4. So it keeps my numbers a little smaller. 2 minus 5 would make negative 3, which just tells me that that x to the 3rd needs to be on the bottom. And 8 minus 1 makes 7. All of that gets raised to the 2nd power. Again, don't forget to bring that exponent with you. So now if I do the power to power rule second, 4 squared still makes 16. 2 times 7 makes 14. And 2 times 3 still makes 6. So either way, again, you still get the same answer. Right? If you're feeling comfortable with the power to power rule, these do not have combo rules, so they won't be like these ones. They'll be more like the normal examples for just the power to power rule. Now's a great time to pause the video and try those out on your own. So if you're checking your answers, you should get 64, x to the 24th, 4 to the 3rd power, or 4 times 4 times 4 makes 64, and 8 times 3 makes 24. Here in the middle, 6 to the 5th power is pretty big. It should be 7,776. A to the 5th power, B to the 15th, and C to the 10th. And last but not least, over the division, 5 to the 3rd power is 125. 3 times 7 is 21. 2 cubed is 8. And 3 times 4 makes 12.